In the geometry of hyperbolic 3 space, the square tiling honeycomb is one of 11 paracompact regular honeycombs. It is called paracompact because it has infinite cells, whose vertices exist on horospheres and converge to a single ideal point at infinity, given by Schläfli symbol 443, has 3 square tilings, 44 around each edge, and 6 square tilings around each vertex in a cubic 43 vertex figure. A geometric honeycomb is a space filling of polyhedral or higher dimensional cells, so that there are no gaps. It is an example of the more general mathematical tiling or tessellation in any number of dimensions. Honeycombs are usually constructed in ordinary Euclidean flat space, like the convex uniform honeycombs. They may also be constructed in non-Euclidean spaces, such as hyperbolic uniform honeycombs. Any finite uniform polytope can be projected to its circumsphere to form a uniform honeycomb in spherical space. Rectified order 4 square tiling. It is also seen as a rectified order 4 square tiling honeycomb. R444. Symmetry. It has 3 reflective symmetry constructions. As a regular honeycomb, a half-symmetry left-right arrow, and lastly left-right arrow with 3 types. Colors of checkered square tilings. 443 asterisk. Left-right arrow. 4111. Index 6. And a final radial subgroup. 443 asterisk. Index 48. With a right dihedral angled octahedral fundamental domain, and 4 pairs of ultra-parallel mirrors. This honeycomb contains the tile 2 hypercycle surfaces, similar to this paracompact tiling. Related polytopes and honeycombs. It is one of 15 regular hyperbolic honeycombs in 3 space, 11 of which, like this one, are paracompact, with infinite cells of vertex figures. There are 15 uniform honeycombs in the 443 Coxeter group family, including this regular form, and its dual, the order 4 octahedral honeycomb. 344. This honeycomb is related to the 24-cell 343, with a cubic vertex figure. It is a part of a sequence of honeycombs with square tiling cells. Rectified square tiling honeycomb. The rectified square tiling honeycomb, T1 443, has Cuban square tiling facets, with a triangular prism vertex figure. It is similar to the 2D hyperbolic uniform triopyrogonal tiling, R infinity 3, with triangle and apyrogonal faces. Truncated square tiling honeycomb. The truncated square tiling honeycomb, T 443, has Cuban truncated square tiling facets, with a triangular pyramid vertex figure. Bitruncated square tiling honeycomb. The bitruncated square tiling honeycomb, 2T 443, has truncated Cuban truncated square tiling facets, with a diagonal dysphenoid vertex figure. Cantilated square tiling honeycomb. The canti-truncated square tiling honeycomb, R 443, has Cuban truncated square tiling facets, with a triangular prism vertex figure. Canti-truncated square tiling honeycomb. The canti-truncated square tiling honeycomb, TR 443, has truncated Cuban truncated square tiling facets, with a tetrahedron vertex figure. Roncinated square tiling honeycomb. The roncinated square tiling honeycomb, TO3 443, has octahedron, triangular prism, cube, and square tiling facets, with a triangular antiprism vertex figure. Roncite truncated square tiling honeycomb. The roncite truncated square tiling honeycomb, T013 443 has rhombic octahedron, octagonal prism, triangular prism and truncated square tiling facets, with a trapezoidal pyramid vertex figure. Omni-truncated square tiling honeycomb. The omni-truncated square tiling honeycomb, T0123 443, has truncated square tiling, truncated cube octahedron, hexagonal prism, octagonal prism facets, with a tetrahedron vertex figure. Omnisnub square tiling honeycomb. The alternated omni-truncated square tiling honeycomb, or omnisnub square tiling honeycomb, H. T0123 443, has snub square tiling, snub cube, triangular antiprism, square antiprism, and tetrahedron cells, with an irregular vertex figure. Alternated square tiling honeycomb. The alternated square tiling honeycomb is a paracompact uniform honeycomb in hyperbolic 3 space, composed of cube and square tiling facets in a cube octahedron vertex figure. Alternated rectified square tiling honeycomb. The alternated rectified square tiling honeycomb is a paracompact uniform honeycomb in hyperbolic 3 space. See also convex uniform honeycombs in hyperbolic space. List of regular polytopes. Coxeter. Regular polytopes. 3rd ed. Dover Publications. 1973. ISBN 0-486-614808. Tables I and II. Regular polytopes and honeycombs. pp. 294-296. The Beauty of Geometry. 12 Essays. 1999. Dover Publications. LCCN 99356678. ISBN 0-486-40919-8. Chapter 10. Regular honeycombs in hyperbolic space. Table 3. Jeffrey R. Weeks The Shape of Space. 2nd edition. ISBN 0-8247-0709-5. Chapter 16-17. Geometries on 3 manifolds I. 2. Norman Johnson. Uniform Polytopes. Manuscript. N. W. Johnson. The Theory of Uniform Polytopes and Honeycombs. Ph.D. Dissertation. University of Toronto. 1966. N. W. Johnson. Geometries and Transformations. 2015. Chapter 13. Hyperbolic Coxeter Groups. Norman W. Johnson and Asia Ivic Vice Quadratic Integers and Coxeter Groups. PDF Canard. J. Math. Volume 51. 6. 1999 pp. 1307-1336.